This is a NEET 2020 exam question from solid state chemistry. The question is, an element has a body-centered cubic BCC structure with a cell edge of 288 pm means picometer, that is 10 to the power minus 12 meter. You are asked to find the atomic radius of the atom. 4 choices are given. The geometry of the BCC structure is given here. Look into the geometrical arrangement. In the center of the cube, one atom is present, but at the edges of the cube, one atom is shared by 8 other cubes. So 1 by 8 atom is present in the edges, but at the center one atom is present. The radius of the atom is denoted as R, whereas the edge length is denoted as A. The relation between edge length A and the radius of an atom R for the BCC structure is given here based on the geometrical arrangement. It is 4R the whole square, which is equal to A square plus A square plus A square. Just go through the geometrical arrangement. So R squared, which is equal to 3 by 16 into A square, and R is equal to square root of 3 by 4 into A. Value of A is 288 picometer. So the answer is square root of 3 by 4 into 288 picometer. In the case of face-centered cubic FCC structure, the relation between edge length A and the radius of the atom R is given based on the geometrical arrangement and Pythagoras theorem as 4R the whole square, which is equal to A square plus A square. Just look here, 4R the whole square, which is equal to A square plus A square. So R squared, which is equal to 2 by 16 A square, and hence R is equal to A by square root of 8. So if a question on FCC may ask, this relation can be used.